everyone, this is Kalpana here. In this video, we are going to see a problem from mathematical induction. So let's get started. Problem: show that cos theta into cos2 theta into cos4 theta into so on into cos2 power n minus 1 into theta equals to sin2 power n into theta by 2 power n into sin theta. Solution: let P of n be the given statement. Then P of n such that cos theta into cos2 theta into cos4 theta into so on into cos2 power n minus 1 into theta equals to sin 2 power n into theta by 2 power n into sin theta. Sin 2 power n into theta by 2 power n into sin theta. So we are given product of n terms in the LHS, right? So here we have to prove that the statement is true for n equals to 1, and we'll assume that the statement is true for n equals to k, and finally we'll prove that the statement is true for k plus 1, that is for n equals to k plus 1, right? So when n equals to 1, we'll consider the first term in the LHS. When n equals to 2, we'll consider the product of first two terms. When n equals to 3, the product of first 3 terms. Likewise, when n equals to k, the product of first k terms. Okay? Fine. Let it. So here we have 1, 2, 3, so on, n terms. Okay? So let's consider nth term as Tn. That is Tn equals to cos 2 power n minus 1 into theta. Right? When you put n equals to 1, you'll get cos 2 power 1 minus 1 into theta, which is equals to cos 2 power 0 into theta. We know that 2 power 0 is 1. Then you'll get cos 2 power 0 into theta is equals to cos 1 into theta, that is cos theta, which is our first term, right? When n equals to when n equals to 1, we'll get the first term. Likewise, when you put n equals to 2, cos 2 power 2 minus 1 into theta will be cos 2 power 2 minus 1 is 1 into theta, which is equals to cos 2 theta. The second term, likewise, when n equals to 3, cos 2 power 3 minus 1 into theta is equals to cos 2 power 3 minus 1 is 2 into theta, which is equals to cos 2 square is 4 into theta. Third term, right? Likewise, when n equals to n, we'll get simply cos 2 power n minus 1 into theta. What I'm trying to say is we are having n theta. Since we are having n minus 1 in the power of 2, so from this we can't say that we have n minus 1 terms. Okay, we have n terms. Okay, don't conclude that we have n minus 1 terms by saying 2 power n minus 1. Okay, fine. See, when n equals to 1, you got cos 2 power 0 into theta. When n equals to 1, you got 2 power 0, that is 0 is less than 1. Likewise, when n equals to 2, cos 2 power 1 into theta, right? So 1 is less than number 2. Likewise, when for n, you'll get cos 2 power number less than n, that is n minus 1. Okay? So we are given n terms here. Right? So when n equals to 1, LHS is cos theta, and put n equals to 1 in the RHS, you get sin 2 power 1 into theta by 2 power 1 into sin theta, which is equals to sin 2 theta by 2 sin theta. Since we know that sin 2 theta equals to 2 sin theta into cos theta, Then this becomes 2 sin theta into cos theta in the numerator by the denominator remains the same, that is 2 sin theta. So you can cancel 2 sin theta, which is equals to cos theta. So here LHS equals to RHS, therefore LHS equals to RHS. From this we can say that P of n is true for n equals to 1. That is, P of 1 is true. Okay, you can also check for n equals to 2. Okay. So let's check for n equals to 2. When n equals to 2, we'll take product of first two terms from LHS, cos theta into cos 2 theta. Okay. Now coming to RHS, put n equals to 2. Which is equals to sin 4 theta by 4 sin theta. Since we know that sin 2 theta equals to 2 sin theta into cos theta, if you replace theta by 2 theta, then you get sin 2 times 2 theta equals to 2 sin 2 theta into cos 2 theta. Then sin 4 theta is equals to 2 sin 2 theta into cos 2 theta. So you can write this as, since we are having sin 4 theta equals to 2 sin 2 theta into cos 2 theta, so you can replace the numerator by this. You'll get 2 sin 2 theta into cos 2 theta by 4 sin theta. Okay. Also we have sin 2 theta equals to 2 sin theta into cos theta. So you can replace sin 2 theta. This is equals to 2 into replace sin 2 theta by 2 sin theta into cos theta. Okay. Into cos theta by 4 sin theta. This is equals to 2 2s are 4 into sin theta into cos theta into cos. We are having 2 theta, okay, not theta. See, sin 4 theta equals to 2 sin 2 theta into cos 2 theta. Okay, by 4 sin theta. So here 4 sin theta gets cancelled. This is equals to cos theta into cos 2 theta. So here LHS equals to RHS, cos theta into cos 2 theta. So from this we can say that LHS equals to RHS. Therefore, LHS equals to RHS. From this we can say that P of n is true for n equals to 2, that is, or therefore P of 2 is true. Okay. Likewise, we can check for n equals to 3 if you want. Fine. Now assume that the statement is true for n equals to k. Assume that P of n is true for n equals to k. Then P of k equals to cos P of k such that cos theta into cos 2 theta into cos 4 theta into so on into cos 2 power k minus 1 into theta equals to sin 2 power k into theta by 2 power k into sin theta. Okay, since P of k is true, Now we can prove for k plus 1. Okay. So let's consider k plus 1 terms. So 1 into cos 2 power, replace k by k plus 1 minus 1 into theta. Okay. We have to write kth term also. K minus 1 into theta into cos 2 power k plus 1 minus 1 into theta. So this is equals to, we have sum of k terms equals to sin 2 power k into theta by 2 power k into sin theta into k plus 1th term cos 2 power k plus 1 minus 1 into theta, right? So here 1 gets cancelled. This is equals to sin 2 power k into theta by 2 power k into sin theta into cos 2 power k into theta. Cos 2 power k into theta. Okay. This is equals to, we can rewrite it as sin 2 power k into theta into cos 2 power k into theta by 2 power k into sin theta. Since we know that sin 2 theta equals to 2 sin theta into cos theta. Okay. If you replace theta by 2 power k into theta, we'll get sin 2 into 2 power k into theta equals to 2 sin 2 power k into theta into cos 2 power k into theta. Okay. Then sin 2 power k plus 1. You can write this as k plus 1 into theta equals to 2 sin 2 power k theta into cos 2 power k theta. Right? So here you are having sin 2 power k theta into cos 2 power k theta. In order to apply this formula, we need some 2 here. Right? So what we'll do is, we'll simply multiply and divide 2. And write the remaining as it is. Okay. So this is equals to 2 sin 2 power k into theta into cos 2 power k into theta by 2 power 2 into 2 power k is equals to 2 power 1 into 2 power k. Bases are equal, so powers must be added. Okay, you'll get 2 power k plus 1 into sin theta. Now you can replace the numerator by sin 2 power k plus 1 into theta. Okay, and the denominator will be as it is, 2 power k plus 1 into sin theta, which is RHS for n equals to k plus 1. See, sin 2 power n into theta by 2 power n into sin theta. Therefore, P of k plus 1 such that cos theta into so on into cos 2 power k minus 1 into theta into cos 2 power k into theta is equals to sin 2 power k plus 1 into theta by 2 power k plus 1 into sin theta. This shows that P of k plus 1 is true. From this we can say that the statement is true. Okay? Therefore, P of 1 or thus. Okay, here we have to conclude that P of k plus 1 is true. Therefore, P of n is true for n equals to k plus 1. Okay, fine. Thus, P of 1 is true and P of k plus 1 is true whenever P of k is true. Therefore, by the principle of mathematical induction, P of n is true. Okay. See, we have not mentioned any n belongs to natural numbers or n belongs to integers. Okay. So simply we'll write P of n is true. Done. So we have seen a problem from mathematical induction in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.